This conference will now be recorded.
Okay, great. So a little bit about myself. I've been kind of working as a principal consultant with VCubC and have been kind of working with a lot of NoSQL vendors and also on the analytics side to churn out some of the decision products for the large MNC companies. And before starting VCubC, I was working with companies like Putney Computers and Global Logic, and have been kind of worked in different part of the world and spent some time in US, and then kind of came back and started the startup out of Noida region. Okay, so let's jump into the topic of interest. And let's ask this question to ourselves as to what is the scale in the data analytics projects. And some of the things that I've seen come very quickly to the mind of most of the participants is the volume, which is really the quantum of data. And people who come with a little bit of analytics background also answer it a way that number of variables or aggregations that they need to do from the complex data sources, which they need to use in their algorithms, which are the analytical techniques, or the reports, the BI reports, or the predictive analytics that they need to do for their business. But what else? And that's something that I would like to do with all of you first, and then basically tell you what I think about it. Okay, so just put in the chat window what you think are some of the other things that you think are needed, or what really defines the scale in the data analytics project. So looking for answer from everyone in the chat window, and I will put those answers in here. So please put in the chat window, and I'll give you 1 or 2 minutes to do that. Okay, so one answer that I've got is the number of data sources, which is which are different in schema. Then or the kind of data itself, that's the second input that I've got. Kind of data, which is unstructured, structured. Okay. Okay, another answer that I've got in the chat window is disconnected data sets, right? So that's from different sources, which really is the first one. Okay. Any other inputs from anyone? What you would like to define as a scale in your data analytics project? Okay, so those are good inputs. I think let me go back to what I think is my take on the scale, and let me just put in here, and feel free to kind of keep giving your kind of answer to the scale in the chat window. So this is what I think is the scale in the data analytics project. And I've written kind of a blog on this on the company page, but let's go over these one by one. So the first thing which I think many of you kind of answered is how many different data silos are spread across uh, basically multiple systems that we can integrate. And The second is the master data management on those data sources, which is handling the veracity in the data. Then the provenance and the auditing, which is for meeting the government regulations and compliances, which is very important today within the kind of perspective of things like GDPR. Then how agile we need to be is the second thing, which is how quickly we can add a new data source and churn out the reports very quickly for the business. And also quickly adding more variables to our analysis, whether we are doing multivariate analysis, whether we are kind of suppose we got a new data source and those have two more interesting variables. How do we map those back to our existing data sources? Another thing is capturing real-time data from connected devices, which is in the purview of the IoT. There's billions of sensors today in the world, so how do we capture all that information? And then the cloud neutrality. From the agile perspective, we want to also make sure that the model that we deployed on AWS should also work on, say, Azure or GCP without any modifications, really. Right? So is our model itself that we have developed is agile enough? And then last but not the least, and is the data privacy, which is how secure is my data? How secure is my model? Am I amplifying any information which is not to be given to certain set of users? Are my data and logs encrypted? The technology solution that I have, does that support it at scale? And things like warm devices, which is write once, read many. And of course, to do all of that from the volume perspective and from the velocity perspective, you need to have uh, the right amount of computing power and storage. So computing power basically to run your models at large scale. And of course, to do that, you need the horizontally distributed architecture on the commodity hardware or in the cloud environment. Okay, so that's the scale. Now the second question which comes into our mind is, with this as defined as a scale, how are you solving the scale problem currently in your project? If any one of you is working in the data analytics project, how are you currently solving that scale problem? Okay, so let's try to fit in this as an answer. So one is, of course, a common answer that I get is that we scale out versus scaling up, and that is kind of supported with things like NoSQL databases, right? Or maybe Hadoop. What else? How are you solving the scale problem? What else are you doing? Okay, so another answer that I have is continuous deployments and DevOps to support that. Okay, and okay, another answer is data integration, data hubs, mapping multiple data sources. What else? Now, if you see, most of these problems are on the engineering side. The answers that I've been getting is still right from the analytic perspective and from the model perspective. Of course, you would need to have the performance measurement of your model itself, right, and then tune it. Okay, so typical ways of solving your scale problem, right? So around this, I basically developed one of the frameworks which I've used successfully in a couple of consulting situations and might be useful for you as well, which I like to call it as a DTD framework. It's a data technology and decision preparedness index framework. So I developed it a couple of years back while I was kind of working on some of the consulting projects. And let's see step by step what this framework kind of describes is the business strategy, case studies, industries, return on investment, right? So that is something that you need to answer upfront as a business user. I was reading an article in the morning today from the Knowledge at Wharton, and someone had written that technology is not something which is digital disruption. It is just an enabler for basically amplifying your business value or kind of supporting your business value, right? So the first step, anyway, in any of the decision products that you kind of want to look at is what is my business case? What is a problem that I want to solve? What is the return of investment that I'm looking at? How much should I be kind of looking at? If it is an existing optimization problem, how much return of investment do I get on that? If I'm building a new decision product, what mission critical applications would it help me develop, and what is the business value for that? Right, so that's one thing. What it kind of ties down to is that for a project to scale or to be successful, you need to have someone who kind of sponsors and champions that project. The second thing is that you want to solve this problem. Do you have enough data? I mean, you want to solve a problem, but have you collected ample amount of data to kind of even build a model or test a model or train a model, right? So that's another thing that you need to kind of focus on. For example, even if you're building a smallest data model, you're kind of starting to build a couple of lakhs of rows or data rows are kind of at least needed to build something meaningful from your data model itself. Then the third thing is, of course, now you have the data, you have kind of got a compliance need, you've got approvals to collect that data, you've kind of got pipelines to collect that data. Now, do you have a right technology infrastructure to support that volume, variety, and velocity of data that is coming in? And then the unstructuredness or the complexity of the data. Right, so that's kind of another thing that you need as a part of uh, your scalability framework, if you may want to call it. And then the last thing is your models itself. You start kind of building out your model. You use your machine learning algorithms. You use your analytical techniques to build your model. It could be either in Python. Spark is getting very popular, right? And then you kind of build out the visualizations for your business for making the decisions. Right, so this kind of framework, if you kind of keep in mind, it's very simplistic. Might think of it like a common sense, but sometimes common sense is difficult to find, and if you kind of follow that, then it kind of becomes easier when you're implementing or scaling your analytical product. So some of the problems in these four areas which I have seen on some of the projects that I have worked on. I'd like to share that and some of the cues in there, and feel free to put in any questions in the chat window or any insight that you might have as a group that you might want to share on some of the problems that I'm kind of building up out here. So in the goal setting itself, one of the problems that I've seen is, and this kind of happens a little bit less today, maybe was more common a while back, is that you hired the best team, you got licenses to the finest software that you can that you've heard of or that you think would solve the problem. You have all the data in the world, right? So you basically did the second and the third item. You were data prepared, you were technology prepared, but you were not business prepared. You already burned 60 50 60% of your budget, but because you were not business prepared, you missed the first step. What do? Right? It's a typical situation of getting fired in this scenario. So I think in this scenario, go back to the whiteboard, set the clear goals. Otherwise, the scalability comes a little bit later on. Even if the business problem is not defined, you would not even know what to scale. Okay, so you need champions and sponsors as the guiding post. And the best way to make investment in big data projects is in the incremental and agile way. And remember, this is not a one-time implementation. You would have to be iterative about it, and so that you can later on scale it. And do not go after unsustainable use cases for too long. Fail faster, adopt. The second typical challenge that I see on the scalability of your analytical model is, are you using the right technology? So a lot of you mentioned one of the scalability problem is that you have a lot of disparate data sources, no clear data integration and transformation strategy, and the data science team who are basically building the analytical model, they want to scale it, they want to test it, they are working very fast on it, and they're asking for more and more data and maybe include more and more data sources continuously. Now, how do you solve that problem if you don't have the right technology? So again, some of the pointers in that area could be, have you looked at the data extraction integration tools like Talent, MuleSoft, NiFi, which can support multiple data sources? Have you looked at NoSQL databases, which can help you develop operational data hub? Now, data hub is becoming a very, very important term for most of the database providers today. Recently, I saw HANA also launched their data hub. One of the NoSQL vendors that I work with, MarkLogic, they have their data hub offering available. And pretty much, if you will see, most of the um, uh, database vendors have started moving from data lake to data hub strategy. And then along with that, do they have the governance and security layer? There are very few databases in the world today on the NoSQL side which are compliant for the government grade security. And that's very important because there are any security leak, any governance leak can basically result into huge penalties, and that will directly hit the ROI that you started with. If you lose your sponsor because of this, the scalability goes for the toss again. Okay, so that's very important as well. And then you need your ELT on highly parallel distributed environment. Now, most of you would have heard ETL, and that's what we have been doing for last couple of decades. But it's now is a time with the agile databases, you can actually go and do the ELT strategy, which is extract your data, load it as is into the schema agnostic databases, and then do the transformation for your analytical needs. Then the third, or yeah, we start from zero. So the second challenge that you see is for scalability is to have the right skill set to execute your big data and analytic projects. And either these professionals are not available, and if they are available, they are very costly. So even if you have solved the business problem, you have set your ROI goals, you have the data sources, you have the right technology solution, or you have bought the licenses where you needed it, or if you're working with open source, you know your architects have developed those solutions in mind. How do you go and implement that? Okay, so that's another thing that you would have to think through. So Existing big data professionals are difficult to find and costly. It's even more difficult to find people who understand the bigger picture and continuously innovate and learn. And maybe you can find a product specific expert, but it's very difficult to find people who can tie the whole solution together, right? So how do you solve that? So reskill your existing team, do internal external analysis about training needs, get that plan executed, and maybe hire 20% of the experts and then reskill 80% needs from your existing team. And this is where some of the things that we are trying to do at Data Analytics Hub as well. And like for big data track. So I think the project, what I've seen more often than not is that you need more kind of polyglot scenario, not just from the programming perspective, but from understanding the whole stack perspective, which is if say you are on a big data engineer, you will need to know Spark, you will need to know Hadoop, you will need to know Kafka, NiFi, you will need to know NoSQL databases, you will know how to integrate and transform your data. And if you're working as a data scientist, you would typically need to know your linear algebra, your statistics, your analytical techniques, right? Your all the regression and clustering algorithms. You will need to know a kind of programming language, either Python or R, to kind of start writing those models or tweaking those models to begin with. Tools like TensorFlow, which kind of makes that whole implementation more easier, and then get into more complex deep learning kind of scenarios. And there are very few people who basically know both of these tracks very well. So most of the people are good if they kind of choose a track for themselves, given the opportunities, given their interest, given their past experiences. Right? There are very few superhumans that I know who know basically both big data track as well as the analytical or the data science track. But there are few people, and they are very well paid, and you can choose to become that over a period of time. But to begin with, you will have to choose whether which track kind of makes more sense for you. Then challenge number three, how can I reuse my existing infrastructure? We have already spent millions of dollars on it, right? So classic problem with a lot of large companies who have spent billions of dollars working with Oracle Stack, working with Microsoft Stack. They already have data warehousing solutions in place with a BI layer sitting on top of it. And they don't want to just throw that away. A lot of their work, day-to-day work, 80% of the work is probably getting managed with that. They want to optimize that, or even some of the newer solutions, they want to kind of use the data which is already out there, right? So to do that, you don't really have to replace everything to begin with, right? And again, as I said earlier in the kind of discussion, is that uh, try to do it in an incremental, agile way. Don't You don't just have to throw everything away, right? So look at your current analytical needs, look at the batch versus real-time needs, think is it really all that you need to replace, or a lot of it can be handled with a current scenario. So let me give you an example. Let me give you a kind of an high-level architecture of or a flow diagram, if you may want to call it, in the current data warehousing scenarios. And anyone coming from data warehousing background would understand this stack. So there's your operational data, distributed data, external market data, which kind of gets ETL using tools like ODIs or SQL Server or business object data integration tool, gets denormalized and goes into the traditional data warehouse either by Oracle or SQL Server. And then you do all kind of OLAP or descriptive inquisitive batch report queries on top of it. And there are different reporting tools which were available from most of these vendors. Now, a company has that already. Now, how do you kind of augment or solve the problem of where you don't want to throw everything away? right? So this stack is very limited. It's not schema agnostic. Any new file with 20, 30 variables would require the model change, right? And final reports to reach to production could take few months, and that's what happens. And even if you scale it from volume perspective to terabytes of data, it will really kind of take a lot of time to do that. So if you augment that with a little bit of big data architecture, and this is a little bit older stack still, the newer would have more later technologies, but this is when lakes were getting popular. So you kind of start moving a lot of your data onto Hadoop as well and create a data lake on top of it. And then do MapReduce jobs to put the output of that into your traditional data warehouses and churn out reports. Also, you can create another integration points with say tool like R, or maybe you can use TensorFlow today, which can then do your analytical models on top of it. You can run those and do the visualization. So a lot of this still kind of continues to run, and you have integrated that with the newer stack. Right, and then from your traditional data warehouse, you can do things like RSQL. The REST APIs are becoming very common today for doing any kind of third-party web service call or creating microservices on top of it. Right. Okay, so challenge number 4. I have a team and a big data project plan ready, so your business side is served, but I don't have data access. So you have your technology, you have your big data team, you have your business ROI plan in place, you know what you want to do, but you don't have the data access, right? Again, classic delay problem. And typically, I think as soon as you think about solving a problem, start requesting for data access. Getting data is probably the most political job to be done on these kind of projects, right? And it takes time. And if you're talking to multiple data sources owners, you will have to kind of take a buy-in from all of them, from governance perspective, from security perspective, and you will have to convince that you have the right technology to basically make sure that you won't falter on that part. Okay, so yeah, this is what I had for today. The big data track is now available on dataanalyticshub.com and open for any questions from the scalability perspective, or if anyone of you would like to share anything in the chat window, maybe your experiences, feel free to do that. Okay, so there's one question that I see, which is, can you tell a little bit about big data tracks? So that's basically a new track that we've started up. This kind of covers the whole Hadoop ecosystem, Spark with SQL data frame, streaming, mlib, and then the Kafka NiFi integrations, and one of the NoSQL databases and data modeling. Okay, and if you go to dataanalyticshub.com, you can find details on what we plan to cover. Some of the FAQs are being answered there. Okay. Okay. Another question that I hear is, which is the NoSQL database that you recommend, which can support such kind of analytical needs? So I would actually point you to the recent Gartner reports. Gartner actually publishes uh, some of the operational analytical databases. And if you will see, one of the NoSQL databases is MarkLogic on the list. And that is something that you might want to explore. And of course, vendors like SAP, and SAP has actually come up with their Data Hub offering as well recently, so they are there. And of course, most of the RDBMS vendors have also come in with their offerings of analytical databases. So you might want to look at the latest Gartner report on that, and that would give you a lot of insight into that. Great. Any other question at this point? Awesome, guys. So, yes, I think I kind of kept a lot of time towards the end for any questions. Okay, so I see another question there. So the question is the person sees a spark on the analytical track as well. So does that make sense? So Spark is kind of becoming very popular for scalable analytics nowadays. What you would observe is that the models that you're building, say in language like Python, or maybe in some of the other languages, can be directly run in Spark, and then you can use the Spark features to basically scale the run of those analytical models. Okay, so in our analytical track, we have kind of included Spark as well, as we think that that's an important kind of tool set for anyone going for that track. And of course, you could argue that you should have things like DevOps and cloud as well on these tracks. So we would have loved to do that, but I think the learning for the DevOps and the cloud kind of becomes a little bit takes you onto a different track. You would need to understand a little bit on the networking side there, and understand some of the infra concepts along with the continuous deployment, and more on SVN kind of a thing. So that's why we can kind of excluded that. And there are a lot of other good learning resources available for those purposes. But of course, DevOps and cloud is definitely something that you want to understand as well. Okay, any other question? Great, guys. So yeah, thanks for your time. It was good to have you all on this forum again. Let me just uh, say thanks to all of you for your time, and feel free to kind of keep be the part of the community, the meetup community that we have, and looking forward to have you all in some of the other meetup sessions. Okay, good luck, guys.